Okay, let's do another example just to make sure, and I will do it in two different ways. So first of all, let's say that I'm going back to the same original example with the same preference, the same B1 has the extra power, but now I want to look on where the sequence 3 announce first, 1 announce second, and 2 announce last. So the sequence is different. We saw that if 1 announced first and then 2 and then 3, then the outcome was that the winning strategy S3. Let's see what is the winning strategy now. So first, let me do it in the same way I did before, but then I'll show you how to do it on a tree. So even though we'll get into the tree or dynamic games later on in a very precise way, but so let me start, and I say here. So I'm assuming that the order is 3, then 1, then 2. So I say to myself, here is 3. Suppose 3 start with S2. Excellent for her, S2. So let's say 3 announce S2. Now 1 has to announce. The next after 3 comes 1. So what 1 will announce? So if 1 announce, one announce S1, okay? If 1 announce S1, then what about 2? 2, now I want to see what happens to 1 if he announces S1. So 2 is not going to announce also S1 because it will be bad. If she announces S3, no majority, even it's bad for her. So she must announce S2, and S2, then both B3 and B2 announce S2. S2 wins, it's bad for player 1. So therefore, B1 is not going to, so B1 in that case is not going to announce S1, he's going to announce S3. But if he announces S3, immediately after him, 2 will announce S3 because it's excellent for her. S3 wins, but then 3 says, oh my God, I announced S2, I ended up with S3, which is bad for me. I'm not going to announce S2. So he's not going to announce S3, which is bad for him. He's not going to announce S2, we explain now, so he's going to announce S1. But once he announces S1, immediately B1 announces S1 to get excellent, and the outcome is S1. So now I want to show you how I do it with a trick. The only thing to realize is that none of the players is going to select a strategy which is bad for that director. So in that case, I start with B3 because it tells me that the order is that B3 is first. Okay? So B3 can go either, B3 is not going to go to S3, it's bad. Either S1 or S2. So I'm writing S1 or S2. After that, who goes? 1. 1 is not going to go S2 because it's bad for her. So 1 can go S1 or S3. S1, S3 here, S1, S3 here. Last is 2. 2 can go, she's not going to go S1 because it's bad. So she can go S2 or S3. So S2, S3, S2, S3, S2, S3, S2, S3. So this is not a full description of the game because I deleted all branches where it's bad for that player or that board member that made the decision there. And therefore, we have a smaller subtree, if you like, but this is the relevant one to analyze, knowing that none of them will select a bad strategy for themselves. Okay. So now the way to do it, and we'll continue to do it later on quite a bit, is to fold the tree backwardly. So I'll start with the last point. What about B2? B2 is indifferent between going here or here because the result is, by the way, let me first of all, here I write the winning strategy. Why? If 3 goes S1, B1, S1, S1 is a majority. So it doesn't matter what 2 does, S1 is a majority. If 3 goes S1, as B1 goes S3, and B2 go S3, S3 is, sorry, none, there's no majority. And if there is no majority, then the decision of one has the power. One chose S3, so it's S3. If it goes like this, S1, S3, S3, S3 is a majority, S3. 3 goes S2, S1, S2, 2 has a majority, so it's S2. S2, S1, S3, no majority. What B1 did? S1, B1 has the extra power, it's S1. S2, S3, S2. S2 is a majority, S2. And here, S2, S3, S3. S3 is a majority, so it is S3. Okay. So first we understand how we got to this. Now I look here and I say 2 should go here or here. Doesn't matter for her because it's going to be S1 no matter. So I put arrows in both cases because she can go both ways. It doesn't affect her. Here too, S2 or S3? Oh, so now let's look on B2 and ask S2, sorry, sorry. B2 here also indifferent, S3 and S3, the outcome. So she doesn't care. Thank you. What about 2 here? Now, I mean, S2 and S1. So she has to compare. If I go here, S2. If I go here, S1. So what will be the outcome? So she compares S2 to S1, but S2 is good, S1 is bad. She is going for S2. Where S2? So she's going to vote here, S2. Here again, she makes a decision to go S2 or S3, and the outcome will be S2 or S3. So she compares S2 to S3, but excellent is better than good. She goes for the S3. One knows all this. So one says, here one, I'm going backward. One says, if I go S1, doesn't matter, it will be S1, excellent for me. If I go S3, it's going to be S3. S3 is only good for me. So for sure, B1 is going here. What about B1 here? If he goes S1, he gets S2 because it continues like this. With the arrow, we get to S2, but S2 is, for S1 is bad. What about if he goes S3? The answer is the outcome will be S3, which is good for one. So for sure, he prefers good on bad. If he goes here, he gets bad. S2 is bad. If he goes here, he gets S3, which is good. So now S3, who started the game, but we folded backwardly, has to make a decision. If he goes S1, S1 is chosen, which is what for B3, S1 is good. If we go for S2, S3 is chosen. S3 is bad. So he goes for S1, and the outcome is S1. The strategy that will be implemented is S1. Board member number 3 starts with S1. Board member number 1 after him goes S1. And then 2, doesn't matter what she does because there is a majority for S1. Okay, so there are 2 different ways. I hope it is clear. There are a lot of examples in your problem set with full solution, either this one. In the solution of the problem set, I put all the, here you have only 2 to the power 4, but before, I mean, in my solution, I put the entire game, which has 3, I mean, all the possibilities, the full game. Here, this is the relevant part of the game to find out what are the optimal strategies of the board members. Good. So, and you have exercises and let's go on. How do I get rid of this one now? I have somebody to help me. Her name is Siu, and she's great. And the only difference between us, it was not recording. Okay, so good. Okay, now it is recording. Yes. Thank you. So, I mean, this part of the game, which you remember 3 to the 9, so I made a mistake. I said 3 to the 9, I thought it's 729, it's much more, it's 19,000. So look, when B1 goes first, B2 second, and B third, the third one, so B1 has 3 strategies, S1, S2, S3. He cannot contingent on anything that he heard before because he didn't hear anything. However, B2 hears what player 1 is doing, and for every choice of 1, she has 3 strategies, so it's 3 to the power 3, and this is 27 numbers of strategies. And B3 has, for each one of the 9 possible pairs that she can hear S1, S2, S1, S3, S1, S1, and all of, there are 9, so it's 3 to the 9. If player 3 has 19,683 strategies, and you saw that with the reduced game that we have, we make it very simple to analyze. Also, I mean, even not with the tree, was much simpler to analyze. But remember, when we consider the full number, that the entire set of strategies is huge. To find the optimal is not that difficult. So you can read it. It's just a remark about how different the sequential game is from the simultaneous game. Okay, next I want to show you the successive elimination of dominated strategies. So I'm talking about strictly dominated strategies. And by the way, nothing, if I delete strictly dominated strategy, like in the prisoner's dilemma, then nothing changed. You get the optimal, then the optimal outcome. Sometimes you cannot delete, or there's nothing to delete. Let's say that I'm taking, here is an example, okay? 1, 2, 2, 1, 1, 2, 2, 1. So, and this is up, down, left, right, 1 and 2. Down, if I believe, I'm player 1. If I believe that player 2 goes left, I should go down. If I believe that player 2 is going right, I should go up. So I cannot compare down to up. Similar for player 2. So I cannot reduce this game anymore. So maybe I cannot even reduce this game anymore. Or maybe I can. So I want to show you how it works. So I'm trying to look if I can delete by strictly dominated strategies. Sometimes it makes sense also to delete weakly dominated strategies, because a rational player will not will not use a weakly dominated strategy. But when you delete weakly dominated strategies, you may have a problem, because it will really depend on the order you delete. Maybe if you start deleting this strategy and later on that strategy, and you move from player to player, you may end up with different outcomes depending on the order of deletion. This has no problem at all if you delete strictly dominated strategies. So let me look and see if you have strictly dominated strategies in this game. So let me compare A to B. 8 is more than 7, 12 is more than 11, 5 is less than 6, so I cannot compare. Okay, so A and B cannot be compared. A and C. 8 is like 8, so if at all it will be something like weakly dominated, I want to not to consider here. However, even here, 12 is smaller than 26, but 5 is more than 4. I cannot compare A to C. So I try to compare A to D. 8 is smaller than 19, 12 is like 12, and 5 is more than 4. Cannot compare. So maybe I can compare A to E. 8 is smaller than 10, 12 is smaller than 22, 5 is like 5, 10 is smaller than 20, 11 is smaller than 18, 9 is smaller than 14. I can say that actually A is weakly dominated by E, but because of the 5 and 5, otherwise it's really strict, the relationship. Otherwise, if you play E, you get strictly more than if you play A, except for 1 point C. However, as I said, I'm interested in strictly dominant strategies. So I don't have domination between A and D, strictly domination. And therefore I figure out that I cannot do anything with A. So I'm going now B and C. Compare B to C. So 7 smaller than 8, 11 smaller than 26, but 6 is more than 4. I cannot. B and D. 7 is less than 19, 11 is less than 12, 6 is more than 4. No way. B and E. 7 is less than 10, 11 is less than 22, sorry, 6 is more than 5. No way. So actually, I cannot do anything with B. So let me try C and D. 8 is smaller than 19, 26 is more than 12. No way. C and E. 8 is smaller than 10, 26 is more than 22. I cannot. So I cannot do anything with A, B, and C. Let me try D with E only. 19 is more than 10, 12 is less than 22. No way. So actually, from the point of view of player one, I cannot reduce anything now. So let's see what happens when I go to player two. So there are, in player two, there are several actually. And, so let me see, for instance, I can do the same thing, okay? But to save your time, here it is. Let's say I want to compare A to B. Thank you. 12 is more than 8, 13 is more than 9, 20 is more than 4, but 14 is like 14. So I can say actually that B is weakly dominated by A, but I am looking for strictly A and C. 12 is less than 15, 13 is less than 14, 20 is more. I cannot do with C. Let me do with D. 12 is more than 10, 13 is more than 11, 20 is more than 19, 14 is more than 10, 10 is more than 0. D is out. But maybe other are out. Why? Because D is strictly dominated by A. But maybe I can, and by the way, now I can move back to player one. Maybe after deleting D, I can delete for player one, etc. So you see how it goes. And let me start with what up, because now the order is not important once you delete strictly dominated strategies. So again, I'm interested in deleting strictly dominated strategies and in a sequence, first this and this, whatever, to see how can I reduce it to the smallest possible table. So as I said, you can continue like this, and then the order in which you delete will not be material. You can delete first D, or you can delete something else, okay? Do I see something that that is easy to say that it is? No, I don't see. But in any event, so let me do it here. So first note here that B is strictly dominated by C. Okay, I start A and D was, but I can also take B out. Why? 8 is smaller than 15, 9 is smaller than 14, 4 is smaller than 6, 14 is smaller than 5, 6 is smaller than 5. So I don't want this. It's strictly dominated. Okay, I prepared in the slide, so it goes like this. Good. Now I may jump to the other player or may continue. Whatever I want, I can do. It will not affect the order I delete. If I delete strictly dominated strategies, the order is immaterial. If I delete weakly dominated strategies, the order may matter. So you may end up with different outcomes. So let's stick to the elimination, successive elimination of strictly dominated strategies. Next note, now I jump to player one. That C is strictly dominated by E after I took it out. Why? Let's look on C and E. 8 is smaller than 10, that I took out. 4 is smaller than 5. 8 is smaller than 20. 7 is smaller than 18. 7 is smaller than 14. Because before I couldn't do it because 26 was more than 22, but now I deleted it. Good. So C is strictly dominated by E. and therefore C is out. Great. This is the time to take another schluck. Good. Let me now move to next. What do I delete? Next, know that in the new game, A is strictly dominated by C. Let me check it after deleting the C. 12 is less than 15, 13 is less than 14, 20 before was more than 6, but it's out. 14 is less than 15, 10 is less than 15, I can take A out. Okay, so let's do it. A is out. So now we're left with a smaller table, but we may continue to do so, to eliminate. So now I go, next, notice that D is strictly dominated by A. This is D and A, let's see. 4 is less than 6, 9 is, no, sorry, by A. 4 is less than 5, 9 is less than 10, 10 is less than 11, 8 is less than 9. Great, I can get rid of D. Now we have even a smaller table, okay? 3 strategies for player 1 left, A, B, and E. 4 strategies for player 2, C, D, E, F. Let's see if we can continue. Next, notice that F is strictly dominated by C. Let's check it. F and C. 11 is smaller than 15. 13 is smaller than 14. And 6 is smaller than 15. Okay, before I couldn't do it because 19, for instance, was bigger than 15. But now D is eliminated. And now I can say that F is strictly dominated by C. So we take it out. Now we have 3 by 3. Player 1 has A, B, E, and player 2 has C, D, E. Good. So it's easy to see now that I can delete D, small d. Why? 10 is less than 15, 11 is less than 14, and 0 less than 15. But also E is strictly dominated now. 9 is smaller than 15, 12 is smaller than 14, and 2 is smaller than 15. Actually, I can take D and D out. Next, notice that E is dominated by C. We say this, but also D. Next, notice that D is strictly dominated by C. Great. So actually, I know exactly what how player 2 will play the game. Player 2 will choose for C, for sure, strategy C. Now, what about 1? Now A and E are strictly dominated by B because by B, 1 gets 6, by A and E gets only 5. Next, notice that A and E are both strictly dominated by B. And I can tell you what are the optimal strategies. Player 1 in this game should play B, capital B, and player 2 should play C. What happens to the outcome? The outcome of the game is 6 for player 1 and 14 for player 2. And by the way, it is not, remember my remark about efficiency. Look, for instance, on what? On, let's say, this outcome that was out. 6 is less than 8, 14 is less than 20, 8 and 20, which is better to 6 and 14 for both players, was eliminated. Okay, so 6 and 14 is the only sensible outcome, even though it is inferior to other outcomes, like 8 and 20. Okay, I'm pretty sure that, I'm not pretty sure, but it looks to me that must be another one. Or no, we don't have. Yes, for instance, look on this, 8 and 19. It's better than 6 and 14. But I want to emphasize again, don't expect the outcome of non-cooperative when everyone is selfish, and my strategy has a large impact on your outcome, and your strategy impacts my outcome, don't expect to get an efficient outcome. You may or may not. You may or you may not. So don't expect, don't be surprised that you get inferior outcome as the only sensible, rational outcome. So 614, and now we are about to start a new concept, actually probably the main solution concept of games, and this is the Nash equilibrium. I'm not going to include it in this session, but I want to tell you why we need a solution concept. Because what we learn by now that we can delete those that are not good strategies, but we may end up with some games that we cannot delete it. And when we cannot delete anymore and we left with some strategies for player one and for some strategies for player two, what do? We do the Nash equilibrium. And what is it? Wait for the next session. Thank you so much.